everyone. Welcome back to Stanford Medicine, Tools for Healthcare Data Science. I am Priya Desai, and this is part 3 of tutorial 2. In this video, we'll go over the basic workflow that we follow to generate the OMOP data from the Stanford EHR data, and we'll also start digging into some of the basic features of the OMOP vocabulary. At the Stanford hospitals and clinics, all of the patient clinical data is actually stored using the Epic medical records system. Many of you who are physicians are used to accessing the patient clinical records via what's called the Hyperspace portal. All of this data is stored in the Epic database called Epic Chronicles on the back end. And this is actually a hierarchical database which is designed to search sort of deep into a patient's clinical records. This database is not really suitable for data analysis where you may want to get summary statistics like how many patients were diagnosed with a certain condition in a certain time interval, say in a certain age group. This hierarchical database, Epic Chronicles, is converted into a relational database called Epic Clarity. And this transformation is actually done using Epic's proprietary product. So it's not something that we, at Research IT do. It's something that is done using Epic's products. And the database, it's converted into the Clarity database. The data in Epic Clarity Clarity is a relational database, and Epic Clarity is what is used as the raw data that is mapped into the OMOP common data model. So it's what is our, it's the raw data that we use, and that's mapped into the OMOP common data model. So there are a couple of things that I think are really important for the users to understand, and one is that this Hyperspace portal allows you, the clinician or anyone who has access to Epic, to access data that actually may reside outside of Epic's EMR records. So for example, as a physician, you can access a patient's x-rays or pathology slides or CT scans, but these data types typically do not reside in Epic. In Epic Chronicles, they actually often reside in a different database. It's a different silo. And while as a physician, you do have access to it, Hyperspace allows you a portal to access that data never really makes it into Epic Clarity. And so we cannot have, you will never see that data in, say, OMOP or even in Clarity. And this is a question that we often hear from our users. Users who have access to Epic saying that, hey, we can see certain data types when we look in Epic, but we can't find it either in Clarity or OMOP. And I wanted to make sure that as a user, you realize that we can only map and bring in, data that actually makes it to Clarity. And everything that you see via the Hyperspace may not actually reside in Epic Chronicles and therefore make it to Epic Clarity. So quick diagrammatic view of the OMOP CDM. This is just, again, a quick reminder. At Stanford, we have transformed our data into OMOP CDM version 5.3. These are the standard tables that you will see in our OMOP data. The tables that are in this blue box are the standardized clinical tables that actually contain all the information of a patient's clinical events. The tables that are in this little red box, the location care site provider table, this is really typically your health system data. Condition era table, drug era, dose era, these are derived elements. These are derived tables. They are derived using the standard clinical data tables. Excuse me, the result schema, the cohort and cohort definition is not populated in our database. It's actually populated using, when we use Atlas, and we're going to talk about, tutorial 3 is all about Atlas. The tables in this little green box, the cost and the payer plan period, It's not populated for the Stanford data, though we're hoping to populate the pair plan period, which will give you some information about, the pair type, that the plan type that the patient has. But the cost tables are not populated, and right now we don't have any plans to populate them. The tables in this little, orange box are the standardized vocabularies, and I think we've mentioned this before. The vocabularies always go in tandem with the clinical tables. So these are the vocabularies. This is the vocabulary tables that goes with this clinical data table. All right, so the Stanford EHR is in the OMOP CDM. So what does that even mean? Basically, what that means is that the data that's contained in those clarity tables have been transformed into the OMOP common data format. Remember, the content could be from different disparate coding systems, and it's now been harmonized into a standardized vocabulary with, we hope, minimum information loss. And what I mean by that is, say something like, pre-2015, we were using, say, ICD-9 CM to, describe all our diagnostic codes, things that are in the problem list, so things that would actually be part of the condition table. Post 2015, it's ICD-10 CM. Both ICD-9 CM and ICD-10 CM has been harmonized into a common vocabulary. The OMOP CDM allows systematic analysis using a library of standard analytic routines that have been written based on a common format, and as a result of this, you can actually use code developed by somebody else using the standard data model for your analysis. And this really facilitates interoperability and reproducible science, and would allow you to generate evidence from a wide variety of sources, right? Really supporting collaborative research. For example, you could develop code here at Stanford using the OMOP common data model, and then your colleague, maybe in another hospital across the country, whose data has also been converted to OMOP CDM 5.3, could actually take your analysis routines, your code, and actually run it there, create the equivalent cohort there, and actually really do an apple-to-apple comparison between the cohort here at Stanford versus the cohort at their institution. Okay, so coming to the most important concept in the OMOP vocabulary, it's actually the concept of a concept. So pardon the puns, but in OMOP, everything is really a concept. So all clinical events in the OMOP CDM are expressed as concepts. And that sort of represents the semantic notion of each event. So concept is really like the fundamental building blocks of the data records, and this really helps to normalize the tables. The concepts are stored in a concept table, and this table is really meant to be fairly comprehensive. So all the vocabularies that are typically used in the public domain have been put into this concept table. All these vocabularies are stacked up one on top of the other. And right now, for example, there are, at this point, there are over 80 vocabularies that are included in, say, the concept reference table. And there are enough concepts to cover any event relevant to the patient's healthcare experience. So, for example, conditions, procedures, exposures to drugs, as well as some of the administrative information of healthcare system, like visits, care sites, etc. All of these are concepts. So the one thing to remember is there is this single concept reference table, and all the vocabularies have been stacked one on top of the other in this table. So this table will actually contain a reference to, say, atrial fibrillation as defined in the ICD-9 vocabulary, atrial fibrillation as defined in the ICD-10 vocabulary, atrial fibrillation as defined in SNOMED, ICD-10, atrial fibrillation as defined in, say, the READ vocabulary, which is what is used in the UK. So the vocabularies that are in this reference table are basically, globally used vocabularies for any clinical concept. So it could be drugs, conditions, procedures, and so on. Typically, there's one concept representing the meaning of each clinical event, and it's designated as a standard. So while the concept reference table has all these vocabularies, OMOP doesn't create a new standard. It decides one of these vocabularies is the standard, and then all the other vocabularies will map to that standard. They pick a different standard for each domain. So one concept representing the meaning of each clinical event is designated a standard. So for example, you could have a mesh code. This is actually a real example. So for example, the mesh code D001281, the seal code 148203, the SNOMED code 494-36004, ICD-9 CM code 427.31, and the READ code G57-3000 all define atrial fibrillation in the condition domain. But only the SNOMED concept is considered to be a standard and is the standard and represents the condition in the data. So once your data has been, so for example, if in the condition domain, SNOMED is the standard vocabulary of choice, once your data has been converted into OMOP, in the OMOP data table, you will only see conditions using the SNOMED concepts. It does not matter what the source vocabulary was. And we're going to go over this in detail. We understand this is a little bit confusing, so we're going to go through many examples of this till this is really clear to you. The other vocabularies or the other concepts in the other vocabularies that are not standard are designated as non-standard, and they are just source concepts. They're all mapped into the standard one. The standard concepts are indicated with an S in the standard concept field. I'm not showing you the fields here. We're going to go through that in the next tutorial in detail. And only these standard concepts are used to record the data in the CDM fields. The one thing I did actually want to say that to just help you understand these vocabularies, standardized vocabularies better, I really urge you to read chapter 4 and 5 in the Book of Odyssey, in addition to these tutorials. In addition, if you look at the Odyssey tutorials, which were part of the Odyssey Symposium in 2018, I personally have found those very useful as well. Their standardized vocabulary tutorial to help me understand exactly how, to actually understand how the standardized vocabularies work. And that is really crucial to you being able to use OMOP for your analysis. So just a quick recap, there's a standardized structure to house existing vocabularies which are used in the public domain. All CDM instances use the same concept table, and this is really the basis of the interoperability of OMOP. Compiled standards from disparate public and private sources, and it contains compiled standards from public, disparate, and private sources. A few OMOP grown concepts, and when we come up to those, we will actually point them out that, hey, for example, there is an RxNorm extension, which is an OMOP grown concept, and so on. Through standardized vocabularies, the OMOP CDM really standardizes the representation of the content. So, for each domain, we pick a vocabulary from the commonly used vocabularies as the standard. So, for example, for the diagnosis domain or condition domain, SNOMED is the standard vocabulary. For drugs, it's RxNorm. For lab values, it's LOINC, and so on. There's another a really interesting site that I want to point you to. It's if you can just go ahead and click on this URL. It's called Athena. And Athena really it's a really nice web interface of this concept table. It's a place where I think you can really get to explore and understand how these concepts are even related to each other. So for example, if you this is the main page, the landing page for Athena. If you're landing on this on the first time, it may ask you to accept SNOMED terms and conditions or something. Go ahead and accept that. And as you can see, these are the main domains that the clinical events have been divided into. So drugs, conditions, procedures, measurements, observations, and devices. So for example, we were talking about atrial fibrillation. So let's go ahead and put in atrial fibrillation into the search box. So now you can see that there's a lot of I get a lot of search results. So let's just go back and explore this GUI a little bit. On the left-hand side, in this left-hand navigation button, there is a domain tab. So if you go ahead and click it, these are the main domains that the OMOP vocabulary has been divided into. So it's the condition domain, device, drug, geography, measured value, measurement, and so on. There is the concept. So remember, everything has been put into the concept table. In the concept table, there are standard concepts, which are the concepts that have been mapped to or belonged to the standardized vocabulary, and then there are non-standard concepts. So for example, for atrial fibrillation, the SNOMED concept for atrial fibrillation is going to be considered standard. The say READ or ICD-9 or ICD-10 concept for atrial fibrillation is going to be considered non-standard in the OMOP world. You can sort of, when you actually do a search, you can filter this by standard or non-standard. So for example, in atrial fibrillation, I say I want only the standard concept for atrial fibrillation, but I only want it in the domain of condition. So I don't want an atrial fibrillation where it could be defined as a device. So I want a standard, the standard definition of atrial fibrillation where it's a condition, and as you can see, that is only one, and it'll always just be it'll typically just be one. So it's this one. So if you go ahead and you click on it, you can actually see this is atrial fibrillation. It belongs to SNOMED. It's a standard concept. It's currently valid, and we'll go through all of that in detail in the next tutorial. So Athena is just a really nice GUI for you to explore, any of these concepts, to understand whether something is a concept or not. So Athena is just, I really urge you to go ahead, poke around, explore Athena in as much detail as you can. And we'll be referring back to Athena frequently during the tutorial as well. Last, before we are done for this particular video, for the next video, you will require, the next video does include using Jupyter Notebooks to access the STARR-OMOP DID Lite dataset in BigQuery from your local machine. And in order to be able to do that, you either need to have the Docker container installed, or you need to install Jupyter Notebooks and the Google SDK on your local machine. There are videos with instructions to do both of them. They have been included in both Tutorial 1 and Tutorial 2's playlist of videos. So please make sure that you've done that before you go on, come for the next video. And I'll see you guys next time. Thank you.
The preceding program is copyrighted by the Board of Trustees of the Leland Stanford Junior University. Please visit us at med.stanford.edu.